Hi everyone. This week we'll be talking about Archimedes, who was one of the greatest mathematicians of Greek antiquity and maybe the greatest mathematician of all time. So Archimedes lived about 250 BCE in the Greek colony of Syracuse, which is in modern-day Sicily. So there are all kinds of interesting stories about his life. For instance, he was said to have created these giant parabolic mirrors that could be used to destroy ships off the coast of Syracuse. He was said to have been able to tow a giant ship a great distance across land using levers and pulleys. And then, of course, there's this famous story about how he rose from his bathtub and went running through the streets in joy, having discovered the principle of volume. So these stories, we don't know whether they're true, but they are interesting nonetheless. What is undoubtedly true is that Archimedes was a brilliant and prolific mathematician. There are a number of really wonderful accomplishments that Archimedes made. For instance, he's the one who helped us know a formula for the area of a circle, and he made a brilliant and very influential related estimate of pi. He also computed the volume of a ball, this formula 4/3 pi r cubed. So that originates more or less with Archimedes. And in fact, he was so proud of that accomplishment that he wanted that formula for the volume of the ball to be on his tombstone as an epitaph. So on your screen at the bottom, you see a figure that shows a circle, and in that circle you see some inscribed polygons. So this figure sort of strikes at the heart of Archimedes' determination of the area of the circle and of his estimate of pi. So the idea is a very modern one. In fact, if you look at calculus, for instance, at least the modern treatment of calculus, the main idea is to take things that we don't know very much about, like, say, some strange area under a curve, and approximate that object very closely by things we do know something about, like areas of rectangles. So Archimedes had this idea for circles, more or less, that, well, he may not know directly the formula for the area of a circle, but we do know, for instance, a formula for the area of one of these inscribed polygons. And his idea was to just simply fill out this circle with these polygons with more and more sides that would form closer and closer approximations to the circle. So he did this with both inscribed polygons, as you see in the figure, and circumscribed polygons. So related to that is the estimate of pi. If I want to estimate pi, that's sort of the same as estimating the circumference of a circle. And I can do that using the perimeters of these approximating polygons. And as I add more sides to my polygon, the better my approximation becomes. And in fact, this method of estimating pi held sway for a long time, maybe almost 2,000 years, until Newton produced a new method of approximating pi using infinite series. So anyway, I hope you enjoy this unit on Archimedes.